This is Algebra 2, Lesson 102. Ladies and gentlemen, we're on page 422, 422. Sums of functions, products of functions. So we are in function notation. That's function notation. That's function notation. All right, so let's remind ourselves, what does this say? Like if I were to say that, if I were to ask that, what is this asking?
If you put 5 in for all the x's, what would f of x equal?
That is correct. If you plug 5 in every place where x is, what's the value of y? Right? So this is your x value. The whole term is your y value. You understand that? I could draw the Cartesian coordinate system like this. Instead of xy, it could be x f of x. Got it? Make sense? Now we're going to take function notation. We're going to add them and we're going to multiply them. That's all we're going to do. We're going to take two equations and add them, or we're going to take two equations and multiply them. You've already done this. You've not done this in function notation. You've just been given two equations and said add them, or you've been given two expressions and you've been told to multiply them. All right, so it's the same process. We're just now in function notation. So I could say, what is f of x plus g of x? And that would be adding. This could also be written as, what is f plus g of x? So addition, and it could be subtraction, right? It would be the same exact. Addition and subtraction of functions can be written either one of these ways, either one. And all that is saying is taking this equation, adding it to this expression. Got it? So it would just be x squared plus 2x minus 3 plus 2x minus 5. And then you combine your like terms. Make sense? That's all it is. Now, if it were subtraction, I would write all of the first terms. It would be minus the entire second function. Here's where mistakes are made. You must distribute that negative to both of the terms, all of the terms in the function that you're subtracting. Does that make sense? Got it? All right, multiplication is typically written, if I wanted to multiply, it could be written f of x times g of x. I guess it could be. But most of the time, it's going to be written f g of x. That means we're multiplying the two functions. And that it would just be multiplication. It would be x squared plus 2x minus 3 times 2x minus 5. And it's distribution of all those terms, right, through multiplication. And then you're combining your like terms. Does that make sense? So we're either adding, subtracting, or multiplying functions, but they're now in function notation. All right? You got it? All right, so let's do your examples. Let's work through your examples. I almost want to say one more thing. Let me just say one more thing. I really debated in my brain. Do I say this or do I not? You're going to learn this. You are going to learn this. Okay, you need to know that this is multiplication. Let me show you something that is not multiplication. I'm going to show you something that is not multiplication, okay? This is not multiplication, okay? It's not. It's not multiplication. Yes.
When you say it, say it's multiplication, you still can't divide one of those by it, right? Like with f of x, you couldn't.
Well, we're actually going to do division, and we will do division next year. Or we're going to do division today, but not in function notation, typically. Okay? But here's what I want you to hear. This is not multiplication. If you see this on the ACT, I'm going to teach you this soon, but it's something different.
F of G.
That is f of g of x. That's how you say this. This is f times g of x. This is f of g of x. And this is more PEMDAS. Solve for g of x, then that output you're plugging into f. Okay? It's fog and golf when we get there.
Golf.
Golf. That's right. See?
Golf.
It's what you love.
There's an L in there. Like
No.
golf.
Golf.
Oh.
But it sounds like golf, doesn't it? Okay, so do you understand what is not multiplication? That is a common mistake that I see students make in math. And I'll remind you of that when we get to fog and golf. All right, now let's do the examples. All right, so look at example 1 on page 423. So we're given h of x equals x plus 3. Okay, I'm going to make this one g of x. Your book uses Greek letters, but we're just going to use English letters. Now it wants to know what h plus g of x equals. And we're just going to add them. So it's x plus 3, that's h of x, and we're just going to add x squared minus 6. Now we're going to write it in proper form. All right, so h plus g of x, we'll write our x squared first. Our x will combine our constants. Final answer. Now they could have asked, what is h plus g of negative 2? So that means not only are we adding the functions, but we're plugging a value in for x. So what would that look like? That would be negative 2 plus 3. That's my h function.
Negative x when they positive 2.
Well, this would be plugging it into the h.
Oh.
This is my h of x, right?
It looks like a negative instead of an equal sign.
Oh, yeah, that's equal, yeah. Now I'm going to plug it into my g function, so that's negative 2 squared minus 6. This becomes a positive because I square the value. So that we have h plus g of negative 2 is, that's 1 plus 4 minus 6. So what is it? Negative 1. So h plus g of negative 2 is negative 1. Yes.
So for whenever you have the two equations, you just combine them.
That's it.
So with the x, oh, I see. So if they had never mind, I see.
Okay, let's change it. If this would have been x squared plus x plus 2,
Mm-hmm.
all right? So then we would have had x squared plus x. Then we would have combined our x squareds. That would have been 2x squared plus x minus 3. Make sense? All right, let's look at 102.2. Our g of x is 2x squared plus 5. We're going to make this the domain is all reals. All reals. Sometimes they make it integers or negative integers. But we're going to do all reals, okay? Because the domain of these expressions is all reals. And now it says find h plus g of 5. This is example 2. All right, so I write my h function first, plugging in 5 for x, so it'd be 5 plus 3. Then I'm going to add to it, we are adding, yes, just making sure we are adding, be 2 times, for x I'm plugging in 5. Make sense so far? So that h plus g of 5, that's 8. That's 5 squared is? 25 times 2. What's 8 plus 50 plus 5? 63. I want you to do these as all reals. All right, so that's adding functions. You could also subtract them, but remember when you subtract them, you have to distribute that negative to the second function.
How do you know when to subtract them?
All right, because it would tell you. It would say, in this case, it would say h minus g of x.
So there's a negative.
So there'd be a negative instead of a positive, instead of a plus. Make sense?
And you would distribute the negative where?
Okay, let's do it. H minus g of x. So I write the h function first. I'm going to subtract the entire g function. So when you write your minus sign, when you write the second function, that is where the negative is distributed to all of the terms. Make sense? Everybody understand that? All right. Now multiplying. It's just the product. We're just going to multiply functions. Got it? All right, so look at example 3 on page 424. It wants us to find hg of negative 4. And h of x is x plus 3. I'm ignoring the domains because we're going to do these all as reals. So sometimes your answer key is not going to match your answer because they're changing the domains. I want you to do as all reals.
So wait, where do they?
Look at example 102.3. H of x, the domain is all reals, but look at g of x. The domain is only negative integers. What that's saying is your domain is your possible x values. What that is saying is you can only plug in negative x values into that function. Okay, we're gonna do all reals, always. Got it? All reals, always. So if you work a problem and it doesn't match your answer key, ask me. I'll tell you if it's right. Okay? We're gonna do all reals all the time. All reals. So g of x is x squared minus 6. All right, so we want h times g. And we're going to plug in negative 4 where x is. All right, so it's going to be negative 4 plus 3. And we're multiplying. Now this is going to be negative 4 squared. Always when there's a negative in here, you're plugging it in for the value of x, and whatever x is raised to, that's what you're raising that value to. Here's where mistakes are made, right here. Because you're not squaring the negative 4. You're making this a negative. But when I square a negative 4, it will become a positive. Minus 6. Did you understand what I said here? This is where mistakes are made. Always on the ACT. There's problems like this oftentimes on the ACT. Here is where every person I tutor makes mistakes.
So it's negative 16.
It's positive. Positive, positive, positive.
That's
Yes.
the first thought.
But whenever there aren't parentheses and it's just a negative squared, then the negative stays.
Correct, but you're always going to have parentheses in your function. Always. When you're plugging it in.
So like, let's say there was a negative 2x and you had to put a negative 4 in, would it be, you would have 2 times, so that would be 8, but then since there's a negative out there, it would be negative 8. Wait.
No. It's just a negative times negative. If it were positive 2x,
Okay.
this is if it were negative 2x. This is if it were positive 2x.
What about like negative x squared?
That be the negative of negative 4 squared.
So it would be negative 16.
Correct. Whatever the number here is what you are plugging in for the value of x. And then once you plug in the value of x, you're going to square it, and then you're going to take the opposite of it. Because we would square before we look at the sign. Plus or minus. That's PEMDAS, right? All right, so that's what? Negative 1. That's 16 minus 6. That's 10. 16 minus 6, right? 16 minus 6. So HG of negative 4 is negative 10. Make sense? Are we good so far? All right, let's look at 102.4. Last example. We have F and G. F of x is x plus 3. It's the same thing, x plus 3. I could have left that on. And g of x is x minus 5. And it wants to know just fg of negative 4. Fg of negative 4.
Did the exact same as the last one.
Well, it's close. So that is negative 4 plus 3. That's negative 1, right? But now this is negative 4 minus 5. And actually, one of these, it says the domain of this is only positive integers, so it's undefined. But I say do it all reals, right? This is one of those examples. We're doing all reals. So FG negative 4, that's negative 1 times negative 9. So FG of negative 4 is positive 9. So it won't match what's in the textbook.
What does the textbook say?
Undefined, I'm sure. Not in the domain. Empty set.
So domain, so not in the